Okay, so special rights number 5. It's going to look a lot like special rights number 4 because, again, just like with the 30, 60, 90, I set them up to be presented differently. And then as I went through them this year, I kind of presented them all the same. All right, so when it comes to special rights, what type of triangle are we dealing with?
Right triangle.
Right triangle. This is the second special right. And if I draw it correctly, I'm trying to make this leg the same length as this leg. There's the 90. And this one becomes 45 degrees right here. If this angle is 45, what's the measure of this angle? 45. And hence the name 45, 45, 90. 45, 45, 90. Just go around the triangle and name the angles, and that's the special right. If you add up all the angles within 45 and 45 plus the 90, how much do you get?
180.
Always, no matter what the shape of the triangle is, whether it's right or obtuse or acute or any of those, or large or small, always add up those 3 angles, always 180. There are 2 ratios to the 45, 45, 90. One of them is an x, and one of them is an x times the square root of 2. What's the length of this side for the pattern? X. What's the length of this side for the pattern?
X.
X. And that leaves you one other.
X.
How do I remember that the square root of 2 is involved with the 45, 45, 90?
Because there's 2 sides the same length.
Okay, I'll take you up on that. There's 2 sides the same length. That's one way to say it.
Oh, and
There's
2 different angles.
Okay, that's another way to think of it. And actually, when I did it, I thought of there was one length in the x and one length in the x squared of 2, so there's only 2 different lengths. So 3 ways you can remember it. And then when you switch over to the 30, 60, 90, all 3 angles are different, so that's the one that involves x times the square root of 3. It's not an explanation of why it's square root of 2 and square root of 3, it's just a memory device to remember when to use which. All right, if this is your pattern, let's run through several triangles. Make up a length of this side.
14.
14. How long is this side?
14.
How long is this side?
14 radical 2.
Fair enough? That's why we love them. That's why they're special. That's why they're cool to us. No calculator necessary, no batteries, no nothing, right? It's already there. The ratios are there. I know one side, I know the other. So just for the sake of practice, say this is 7 over here. How long is this side?
7 radical 2.
7 radical 2. How long is this side?
7.
Done. The complication comes in if they give us the length of this side. Let's start with an even number. Give me an even number for the length of the hypotenuse. 22. If the hypotenuse is 22, how long is this side? And once we know this side, we'll know that side. Fair enough? How do you figure that out? I like that very much. True. Because if I know the x value here times radical 2, whatever that x value is times radical 2, it's got to equal 22. That's true for the model. Very good. What is x? Let's guess at it. Let's do a guessing check. What would we have to multiply by square root of 2 to get 22? I like the way your brain is going. But if it's just 11, it would be 11 times square root of 2 would be 11 square root of 2. Right? So it can't be just 11.
11 times 2?
What?
A fraction?
11 times 2 times square root.
So let's say it was, yeah, you both said it at the same time and then I couldn't hear either. So I like the 11 square root of 2 because square root of 2 times square root of 2 produces what? If x was 11 square root of 2, let's drop it in so your brain can see it. There it is. That's the length. If you now drop that into x and you say 11 square root of 2 times, because it's dropping in front of this square root of 2, so there's 2 of them, right? What's square root of 2 times square root of 2? Good. And there's still the 11 in front of it. So 11 times radical 4, but what does radical 4 simplify to?
2.
And 11 times 2 is what?
22.
So what's the length of this side?
11 radical 2.
Now that you see it, does your brain process and go, okay, that makes sense? So do a quick one. Let's say this was 10 right here. If this side was 10, ready, Tiffany? So pretend this side's 10 long. What would x have to be over here? Ding. Right? Do you see that? Once your brain starts getting in the mode of this, it can go very quickly. So let's complicate it only slightly. Let's make this an odd number, right? That's what we did last time. Because it's even, so it divides well by 2. And that's what's happening when we multiply radical 2 by radical 2. Let's say the triangle had an odd length side. What do you want? How about 11? How long is the side?
11 halves radical 2. Is it right or no?
And how can we test it? Drop it into the x here. So 11 halves radical 2 times the radical 2, right? That's the pattern. If you tell, whatever this is, drop it right in front of a radical 2 and proceed to multiply. So I just literally take the 11 halves radical 2 times radical 2 is radical 4, still 11 halves in front of that, times. What's radical 4 simplified to?
2.
Still 11 halves in front of that. If you can keep in mind that the 2's up in this position, what happens to the 2? What's left?
11.
Now, I thought you might have gone for the decimal first. You went for the fraction first, which is actually the better way, the more robust way that a math person would like to do it. But what if you went for the decimal way? Because your brain might think decimals more easily. What is 11 divided by 2?
5.5.
Remember 5.5? So I thought you might say 5.5 radical 2 here, which is technically correct also. And if it was 5.5, we could have said 5 1/2. Remember that? What's 2 times 5? 10. Plus the 1 is 11. Put it back over 11 halves. So boom, 11 halves radical 2. Pretty cool? I mean, I feel like you know special rights on some level. Maybe not totally, but you know something about it. Fair enough? Okay, so stop this one and then I'm going to roll to the next one.